Introduction of food irradiation. Food irradiation is a food safety process and preservation technique that uses radiation to kill germs that can cause food poisoning or foodborne disease. Food irradiation is safe as it does not change texture or appearance of food and does not make food radioactive. At low dose, irradiation extends the product shelf life. At high dose, this process kills insects, molds, bacteria, and other potential harmful microorganisms. Food irradiation is considered as a core method as it does not use heat to kill germs. The irradiation process happens after a food is produced and packaged. Food enters a chamber where it is exposed to a specific amount of radiation. The radiation penetrates the food and kills germs or prevents them from multiplying. And it does not linger in the food. Irradiation is one more protective step, but it does not replace other food safety measures. The process also helps to delay ripening of fruit and vegetables and control the sprouting of root crops. So, what is gamma rays? Gamma rays is a form of electromagnetic radiation, EMR, that has high energy and it is used to penetrate the food items. It is similar to X-ray and it is emitted from radioactive form of the element cobalt, which is cobalt-60. Gamma radiation is used routinely to sterilize medical, dental, and household products and also used for the radiation treatment of cancer. In the utilization of food irradiation, ionizing radiation are gamma rays. Gamma irradiation is safe, reliable, and highly effective at treating a wide variety of products with varying density. The high penetration characteristic of gamma rays allow for the sterilization of a great variety of products in any size package. The irradiator can be customized for large product volumes and specialty precision processing. It is used for inhibition of sprouting in bulbs and tubers, insect disinfestation of cereals, pulse and grains, microbial decontamination of dry species, and such on for preservation extension by applying predetermined radiation dose.
So now I want to talk about the mechanism of gamma rays in the aspect of food irradiation. The first step is ionization and formation of free radical. Gamma rays have high energy and short wavelength to allow them to penetrate deeper into the food product. When the gamma rays interact with atoms or molecules in the food, they can ionize them, means they can remove the electron from the atoms and creating the ions. This process may also generate free radical, which are highly reactive molecules with unpaired electron. And the second step is cellular damage. The ionization and free radical formation disrupt the normal structure of cell in the microorganism as well as enzyme and other biomolecule in the food. This disruption damage the chemical bond in the cellular DNA, RNA, and protein, and preventing the microorganism from producing repeatedly or functioning properly, which reduce the illness and spoilage. And the third step is microbial inactivation. One of the primary purpose of using gamma rays in the food processing is to kill and inactivate the microorganism that may cause the food spoilage or pose a risk to the human health. Gamma irradiation can destroy the bacteria, parasites, molds, and some virus and extend the shelf life of the food product. And the slide shown is about the food preservation technique by using the irradiation method. Food such as fresh meat and spice leave processing facility and arrive at facility that use radiation to kill the germs. At the irradiation facility, food rides on the conveyor belt through the irradiation chamber. So in the chamber, food pass under a beam of radiation, and this process kill the germ by breaking the bonds that hold the germ's DNA together. This can inhibit the DNA synthesis in the pathogenic microbes and affect the ability of the cell to survive and multiply. Once the food leaves the irradiation chamber, most of the germs are destroyed.
Alright, now we will proceed to my part, which is the advantages of gamma ray irradiation. Firstly, the advantage of gamma ray irradiation is extended shelf life through insect control. Irradiated food prevents food wastage. Gamma ray irradiation is effectively in controlling insects and pests in store grains, dry fruits, and other food products. It disrupts the reproductive cycle of insects by preventing infestation without the need for chemical pesticides. Next advantage of gamma ray irradiation is quality retention. It allows for the preservation for the nutritional qualities of food and can help maintain the nutritional content of the food. For example, nutrient loss during irradiation is same to the amount of nutrient loss during cooking, freezing, and canning. Furthermore, the advantage which is safe to consume. Irradiated foods do not become radioactive and do not give off radiation. For example, eating irradiated food does not expose us to radioactive materials, which is safe to consume. Next, the advantage of gamma ray irradiation is cold sterilization. Gamma ray irradiation is a cold process unlike traditional heat treatment. It can apply to heat-sensitive foods without causing significant change in terms of texture and flavor. Cold sterilization is particularly advantageous for certain fruits and vegetables. In addition, the advantage, which is versatility. Gamma ray irradiation is applicable to a wide range of food products, including fruits, vegetables, spice, grains, and meat. This is suitable for both fresh and processed foods. On the other hand, the advantage of gamma ray irradiation is dosimetry control. The dosage of gamma rays can be precisely controlled through dosimetry. The dosage can be calculated accurately to ensure that food receives the appropriate level of radiation for effectively microbial reduction without compromising safety or quality. Thus, the advantage, which is prevent foodborne disease, gamma ray effectively kill or inactivate bacterial, parasites, and other microorganisms present in food. For example, E. coli, which is shown on the diagram. Gamma ray significantly reduces the risk of foodborne illness by making the treated food much more safer for consumption. Last but not least, the advantage of gamma ray irradiation is reduced dependency of chemical. This is beneficial for consumers who may prefer food products with fewer chemical additives. Application of gamma ray can replace the usage of chemical additive to preserve food. Therefore, gamma ray can reduce the exposure of cancer from the food. And that's all for my part. Thank you.
I'm going to talk about the disadvantages of gamma radiation towards food. Firstly, gamma radiation can influence the moisture content of foods, potentially leading to changes in texture and overall product quality. Next, gamma radiation is not suitable for high-fat foods because it can lead to the formation of free radicals in fats, initiating lipid oxidation. This process results in the breakdown of lipids, leading to off flavors, changes in aroma, and a potential decrease in the nutritional quality of the food. Moreover, gamma radiation leads to the formation of radiolytic products. Radiolytic products are the byproduct resulting from the interaction of radiation with food components. Radiolytic products can include free radicals, ions, and various reactive chemical species. These reactive species can participate in further chemical reactions within the food, potentially affecting its flavor, texture, and nutritional content. One common example is the radiolysis of water, resulting in the generation of various reactive oxygen species. The overall reaction can be represented as follows. Water reacts with the radiation and will form hydrogen ions, hydroxyl radicals, and hydrogen peroxide. The hydroxyl radicals and hydrogen peroxide formed during this process are examples of radiolytic products. Furthermore, gamma radiation causes public perception towards the misconceptions and concerns about the safety and long-term effects of consuming irradiated products. They may have concern that this method may result in less stringent food hygiene and handling practices, as irradiation is not a substitute for good hygiene practices. Marketability of irradiated foods may also be affected. Lastly, gamma radiation requires high cost of implementation in setting up and maintaining facilities for gamma radiation. It will become burden for some food producers and processors.
After explaining about these advantages of gamma ray, we are going to talk about application of gamma ray in food. Gamma rays can be utilized to improve food safety through food irradiation. This process involves exposing food products to a controlled amount of gamma rays for eliminating harmful microorganisms, insects, and parasites. Firstly, gamma ray can extend shelf life of food product because it will kill bacteria, virus, and molds that are presented in food. For example, Salmonella and E. coli can be killed through gamma irradiation. As a result, the risk of foodborne disease can be reduced. Besides, gamma irradiation can inhibit the growth of yeast and molds. The genetic material of the microorganism will be induced and damaged by gamma rays. This process is crucial for preservation of spices and herbs. Furthermore, gamma irradiation can help to slow down the natural decay processes. Gamma ray will disrupt and damage the DNA of microorganisms. This interference with their biological processes that can slow down their growth, which reducing the rate of decay and spoilage in the food. This allows for a better preservation of the nutritional quality and sensory characteristics of the food. Gamma rays can also be used to control insects from infesting the food. The irradiation process will disrupt the insects' reproductive cycles to prevent damage of food. This application is particularly useful for controlling pests in grains, dry fruits, and spices.
Moving on to the fifth point, gamma irradiation can be applied as a quarantine treatment for imported food products to meet ISPM, which stands for International Standards for Phytosanitary Measures. Gamma irradiation prevents introduction of harmful microorganisms to new regions or countries. Besides, gamma irradiation can also prevent spreading of plant diseases by inducing changes in plant genetics. New traits such as resistance to disease will be developed. Next, sprouting can also be inhibited by gamma irradiation. Growth of buds and sprouting in root vegetables like onion are delayed to maintain the quality of vegetables during storage. In addition, gamma irradiation is a great tool to sterilize foods for storage up to years without the use of refrigerators. Last but not least, gamma irradiation can be applied to fulfill the purpose of enzyme inactivation in foods. This in turn prevents enzymatic browning in food and maintains the quality and freshness of fruits and vegetables.